In this section, we will learn about RC circuit with AC power supply. Okay. RC circuit consists of R, a resistor, and a capacitor. The total impedance of this circuit is given by the resistance plus the impedance of the capacitor. This is the impedance of the capacitor. The impedance of the capacitor is equals to negative J times XC. XC is called the reactance of the capacitor. And the equation of XC is just 1 over omega C. Okay, C is the capacitance. Okay, the value of the capacitance here, and omega we have seen previously is the angular frequency, which is given by 2 pi f. F is the frequency. Okay, so in your question sometimes the value of the omega is given, then you can just use it straight. If not, if the frequency is given, then we have to multiply by 2 pi to get the omega. Okay, so that's all is explained here. Your XC is the reactance, capacitive reactance. ZC is the capacitive impedance, which is given by negative JXC. And then this is your angular frequency. Once we have the impedance, then we can find the current just using the Ohm's law. Current is source voltage divided by the impedance. Okay, E divided by Z. Let's look at an example here. Okay, here is RC circuit where the value of R is given, C is given, omega is given, E is also given. Step 1, we find the total impedance. Okay, to find the total impedance, we just use this equation and substitute the values. Okay, we substitute R with 1K. Omega, since omega is given, we just substitute it here, 1200. And the capacitance is 1 micro. Okay, then we use your calculator to simplify. Okay, here be careful, we have to do the real part and the imaginary part separately. So the real part is just 1K. Imaginary part, just simplify this. It's very easy. Just simplify this part. You'll get about 833, and then we write it together here. Okay, and then this step we convert this rectangular form to a polar form. How to do this conversion, we saw it in the previous section. If you're not sure, go and refer back. Okay, you can try in your calculator. It's just a few clicks in your calculator. You can convert this to this. Now we have the impedance. The next step is to find the current. Current is just E over Z. So we write the E here. The source is 15 and the angle is 0. And Z, we write the polar form, 1302, and the angle is minus 40. Okay, so how to do this division? To divide, it's very simple. The magnitude we divide as normal. Okay, just 15 divided by 1302. Okay, just normal division. You'll get 0.0115 and write the value here. For the angle, we have to be a little careful. It's not divide. When we divide two angles, we have to minus them. Okay, so this is 0 minus negative 40. Okay, also have to be careful. If you are not sure how to do it, just use your calculator. You'll get 40. Okay, because negative and negative can become positive. So this is 40 degrees. So the division here, we get this value. Okay, so it's, if you know how to do, it's very simple. We just divide the magnitude and minus the angle, we get this. So we have found the current. Next is to draw the phasor diagram. To draw the phasor diagram, E, the angle is 0, so we just put it straight here. This is 0 angle and we label it as E. And for I, this is I, yeah? the angle is 40. So 40 means positive angle, we draw it on top. So we just draw this I and you write the angle here. That's all. That's all for the phasor diagram. Next is indicate if which one is leading, I or E. If the current of I is positive, that means I is leading. Okay, and you can also see here I is above. So I leads E. That's all. That's all for this section. Thank you.